So there's some significant differences between the desktop and a distributed file system. The file system on your desktop is optimized for specific consumer workloads. The file system for a distributed file system is optimized for larger workloads, for larger workflows, with different price and performance focus points. So let's start first with the scientist's desktop environment and understand that file system, and then we'll make a nice evolution into what a distributed file system looks like. So we have our scientist and their laptop. And we're going to go a little bit more into this laptop when we actually think about the file system. Okay, so what's on the laptop of this, or the file system of this laptop? We know it has a hard drive. And a hard drive is just a physical device. So that file system actually will need to be formatted onto the hard drive. So you're going to have to format this with some sort of file system. And when you format that, you might put a FAT32 or an NTFS or some other sort of file system. Okay? That often comes through the operating system. So then the operating system can then leverage that particular device. And then on top of the operating system, you have applications that can use those files. Okay, and the applications will use those files, or you can think of just your file browser as an application. So what is that? So you can think of an application such as your Finder or a Windows Explorer. In addition, when you're thinking about your laptop, you're thinking about storage and a file system. You can mount, and you've done this, you've probably mounted a flash drive and then ejected it, right? So you mount those things in. So instead of just your hard drive, you could mount in a flash drive, right? Or you can mount into that operating system. We'll put up here, this is going to be our external hard drive that's going to get mounted in. All right, so we can mount in additional storage, and usually you need to format those too. Sometimes they'll come pre-formatted for you so that you already have a formatted USB flash drive. But you have to tell it, the operating system and the computer, what to do with that raw storage, whether that be a hard drive, whether that be a flash drive. So this is where most folks are comfortable to some level. What happens, though, when your 2 terabyte hard drive is not enough for the 20 terabytes of science that you want to do? For data-intensive science, what's your answer? How do we get to 20 terabytes of data? So let's take this to the next level. How do we make our Uber laptop? How do we make a really powerful desktop? How do we get to 20 terabytes? Well, it turns out the first answer, let's just go buy a 20 terabyte drive, does not exist. So when you hear about big data, there is not one big 20 terabyte, 200 terabyte. There's not one big 5 petabyte hard drive out there. It doesn't exist. We need to start aggregating drives together. So we'll make this guy disappear, and let's go ahead and design a system using hard drives that we can actually buy. So let's design a system with multiple hard drives for our scientist. And this is our next step towards a distributed file system. So how do we do this? I can go out and I can buy 4 terabyte hard drives. And you say, okay, if we wanted to get to 20 terabytes, then I can just buy 5 of these. And I have my 20 terabytes. Now here's the challenge. What does that look like to the operating system? It looks like independent drives at best. We may want an actual 20 terabyte space, and that gets a little more complicated. For that, traditionally what we're going to do is we're going to put a hardware layer, you do a software layer, but typically you're going to have a hardware layer for RAID. So you have this redundant array of disks, and we can tie those together in various forms. We won't have time to go into all the different forms of RAID in this lecture, but you can understand that there's some way of aggregating these together and reporting to those the operating system so that we can see 20 terabytes. Now typically, one thing you will see in a RAID array though, is you will add more You say, why would you want to add more? You would add more for redundancy. You do something called parity, and so we can lose one of these drives, and we can go ahead and keep on operating. But now we can aggregate drives together. So excellent. I have an operating system. Now I can get my 20 terabytes. The question then, why do we need distributed file systems? Okay, so this hardware RAID will eventually become a bottleneck. It will have to somehow magically make all of these perform, and that's a little much to ask for the hardware RAID. We get new bottlenecks here now. Bottlenecks at the operating system and bottlenecks at the network. How do we get data out of this machine if we only have a 1 gig network on the machine or a 10 gig network on this machine? So folks thought about this and they said, aha, instead of designing this one machine and growing it out, which can be expensive, if we want to go an order of magnitude bigger, we don't want 20, we want 200, or another order of magnitude, we want 2 petabytes. Now this can become our building block. So we take this, and for our distributed file system, we now have numerous servers that all have their RAID all the way. And so we have all these systems. Great. Now I can just scale this up. If I could put 20 terabytes here, and I want 200 terabytes, I just do 10 of these, and I just scale this guy out. Someone said, this is fabulous. I don't have to go to an extra expensive version of this. I can go with whatever's optimal here, and to get to my petabyte, I can just scale that. There was a challenge. Okay, where did your file go? This poor scientist over here doesn't know where his files went. You've got 10 servers, you've got 100 servers. Where did your file go? You don't know. Here you knew, 1 operating system, 1 machine. Here you knew, 1 operating system, 1 machine. Over here, now I've got to my petabytes, but I have no idea what has happened. So at this level, we have to now introduce another layer, which is the software layer, which becomes our distributed file system. And this distributed file system has been implemented many different ways. And we're going to talk about those through the course of today's lecture. We're going to look at different adaptations. If we have a file system here that knows where my files are, so what is on this file system? I know locality. I can cache files that become hot for performance. I can make files redundant for both performance and for reliability. There's a lot of things I can do now on this layer with my files for performance reasons. And we'll talk about those throughout the rest of the lectures. We look at different file systems and what they've chosen to do in this. But this is the general concept for, we went from a laptop, we added a lot of drives with hardware, and then we realized at some point the cost-effective performance was to scale in this way, but then we needed another distributed file system. So with that particular paradigm, we can now, with a client here and some level of server over here, have a distributed file system where we can access these as we would, in majority of cases, a POSIX file structure way that we're used to in a high capacity with new feature sets that weren't available in either of these two. We're excited to look at all the different opportunities through the rest of this lecture.